Okay, here we've got a question from the June 2010 paper, and we can see we've got a block with forces on it. There's friction, there's going to be acceleration. So that's the topic area we're in. So, firstly, we've just got to draw and label a diagram to show all the forces acting on the block. Okay, so I can't do it on their diagram, I've got to draw my own. So here's my detailed diagram of the block, just like a detailed diagram of anything at all. Might as well draw the table. Okay, so what forces will act on it? Well, I've got a P, which are already given to me. Okay, the only force that can act by something that's not touching it is the weight, which is mg, but the mass is 10. It's up there. So 10g is the weight. And then in terms of things that are touching it, there's something exerting this force P, and also the surface is touching it, so it can exert a push away from it, which is a reaction force size r, and we can have a frictional force. Now the friction is going to tend to resist it slipping. If it's slipping at all, it's slipping with this force P, so friction must be acting to the left. So there are my four forces. I've labelled them, so I've done part A. That was A. B1, I've got to calculate the magnitude of the normal reaction force. Okay, so from this point onwards, I'm going to use the fact that, well, what does it tell me initially? Okay, it doesn't tell me whether it's accelerating or not to begin with. Okay, but if I read ahead, I can see that I'm finding the acceleration later. So I probably am not going to use all of this till I get to part C, but I might as well just set up my resultant force, which is four forces added together. And because I know it's going to be accelerating, I can equate this to MA. Alright, so F, resultant force, equals, RF I should have said, equals mass times acceleration. Mass is 10. Acceleration, I don't know what the acceleration is, but I do know the acceleration has got to be along the table. It's not going to accelerate up in the air or down, so I can write A0 for my acceleration. Okay, right, so I just need to fill in all the forces. So I've got a F in the negative x direction, minus F0, R in the positive y direction, naught R, P in the positive x direction, P naught, and 10g downwards, that's naught minus 10g. Okay, now in this part of the question I'm doing, I've got to find out about the reaction force. So I'm going to be looking at the y line. So y is telling me that R minus 10g equals naught. So R is going to equal 10g, which is 10 times 9.8, which is 98 newtons. So I've got an answer. Okay, and then B2, I've got to find the maximum friction. So I want to find F max, and we've got to find, we know the equation for F max is F max equals mu times R. Okay, do I know what mu is? Yes, it tells me the coefficient of friction is 0.5. So that is 0.5 times R, but R I know is 98, so 0.5 times 98 is 49 newtons. Okay, and then the next part of the question, given that P equals 30, state the magnitude of the frictional force acting on the block. Okay, so why do I need to know P? Because we still haven't established that it's accelerating yet. Okay, so I could have up to 49 newtons of friction. Now in this part of the question, P is only 30. So I don't think we are going to get acceleration in B.E2. We've got 30 newtons this way, so there's more than enough friction available to stop it from slipping. So F isn't going to equal the 49. In this part, F is just going to equal the 30 newtons, because that's all that's required to hold it in equilibrium. So that top line, okay, the acceleration at the moment is 0, and the top line is just telling me that F equals P. Alright, but in part C, we've got a bigger P, so this P is going to outweigh the largest possible F, so that means it will slip, so therefore F will equal F max, so which of course is 49. So therefore the y line of my force, no sorry, I've done that one already, the x line of my forces is telling me that minus 49 plus P equals 10a, and of course P is 80 in this, so minus 49, that's 31 equals 10a, because minus 49 plus 80 is 31, so a equals, it's going to be 31 divided by 10, 31 over 10, which is 3.1 meters second to the minus 2. That's my acceleration, and I finished this question.